Hi friends, in this video we solve random variable related questions asked in GET exam. The first question is, a continuous random variable x has a probability density function f of x is equal to, they have given probability density function f of x is equal to e power minus x, where x varies from 0 to infinity. What is the probability? We have to find what is the probability of x greater than 1. Right, so if we know f of x, then probability is given by x integral minus infinity to plus infinity f of x dx. So what we have to find is p of x greater than 1. So the limit varies from 1 to infinity. So 1 to infinity, f of x is e power minus x dx. Right, so that will be e power minus x by minus 1. Fine. So where integral varies from 1 to infinity, if you simplify, what you get is 0.368. So option A is the correct answer. Right, okay, next one. Two independent random variable x and y are uniformly distributed. So it is uniformly distributed in the interval -1 to +1. Right? The probability that maximum of x of y is less than half. That is the question. It's a beautiful question. Let us see. Right? So it's a uniformly distributed random variable. We know uniformly distributed random variable, the PDF will be like this, where it is distributed -1 to +1. This is -1, this is +1, right? So it is A, it is B. This is 1 by B minus A, right? In general form we know it is 1 by B minus A. So 1 by B is 1, A is -1, so it is 2, or 1 by B minus A, right? This is the PDF. So we got distribution, probability PDF, we got it, right? Next, what we have to find, they ask the possibility, this is two independent variable, x and y are independent. So x and y are independent variable. So that is very important. It is x, let us assume this is y. So both are great. What is the probability that maximum of x of y is less than 0.5? This is, let us assume this 0.5. Maximum of x of y is less than 0.5. Right? So the probability that maximum of x of y is less than 0.5. So this is the condition. So what we have to find, p of maximum of x comma y is less than 0.5 is equal to what? Right? So p of x comma y, you see x and y are independent variable. So p of maximum of x comma y is equal to x must be less than half, because both are independent. I split it, p of y less than half, right? So what is the p of x less than something? We know just now only I told, once you know distribution, probability is given by p of x is equal to x is equal to -infinity to +infinity f of x dx, right? So this integral f of x dx is having some other meaning. What is that? Is area under the curve. Integral is nothing but area under the curve. Whenever we have a uniformly distributed random variable, you use area under the curve. Don't go for integration, because the other name for other meaning of integration is area under the curve. So when x is less than 1 by 2, what is the area under the curve? X is less than half means this area, only this shaded region. So what is the area? This length is up to this one, it is 0.5, 1.5. This is y-axis, it is 0.5, right? So 0.5 or 1 by 2. So it is 1 plus 0.5, 1.5. So 1.5 is nothing but 3 by 2 into length into breadth. Breadth is half, 3 by 4. Similarly, y is less than 1 by 2. Y is less than 1 by 2 means this is y 1 by 2. Less than 1 by 2 means again the bottom area. So this is shaded region. So what is the area? Here again the width is 3 by 2. This is 1, this is 0.5, 1.5. So 3 by 2. Breadth is 1 by 2. So again 3 by 2 into 1 by 2, 3 by 2 into 1 by 2, that will be given by 9 by 16. So the probability of maximum of x comma y less than 1 by 2 is 9 by 16. So whenever we have a uniform distributed random variable, don't find integration because it is a rectangular shape. So you use area under the curve notion, right? Simple logic. Next problem. Okay, again you see a zero mean random signal is uniformly distributed. Again this is uniformly distributed. This is also a wonderful question. Between limits minus a to plus a. So when they give uniform distributed random variable, first draw the diagram, no problem, right? The PDF diagram. So x varies from minus a to plus a. This is minus a, this is plus a. It is 1 by b minus a. So this is a, this is b. B is a minus or minus a. This is 1 by 2a. So this is what our f of x PDF, right? Okay, so and its mean square value is equal to its variance. Mean square value is equal to variance sigma square. What is the RMS value? See, RMS is root mean square value. That is the logic. That's what they ask, right? So first what we have to do, we have to find variance. We know for a uniformly distributed random variable, variance is given by b minus a squared by 12. Here b is a is minus a, that is squared by 12. 2a is equal to 4a squared by 12. 4a squared by 12 is equal to a squared by 3. So mean square value is equal to variance, right? So mean square value is equal to variance, that is equal to a squared by 3. What they ask is root of mean square value. Simple. Root of mean square value. This implies RMS is equal to root of mean square value. That is equal to a by root 3. So option A is the correct answer. That is the logic, right? Simple problem. Next one. X is uniformly distributed random variable. Again you see uniformly distributed random variable that takes values between 0 and 1, right? So first we draw the diagram, PDF diagram. Okay, 0 and 1, right? So x varies from 0 to 1, right? That is the first thing we must know. Fine. Okay, next what is the thing? 1 by b minus a. So 1 by b is 1, a is 1, 0. So 1 by 1. So f of x we got, right? So what is the value of e of x cube, right? So e of x cube is given by integral minus infinity to plus infinity x cube into f of x dx, right? F of x dx. So but here x varies between this x varies between 0 and 1. So integral varies from 0 1 to 1 because the integration with respect to x only. So 0 to 1 x cube, f of x is 1 only. So dx. So x power 4 by 4, 0 to 1, that is equal to 1 by 4. So option C is the correct answer, right? Simple question. Next one, it is also another important question. A PDF is of a form k into e power minus alpha x. So f of x I can write k into e power minus alpha x mod x, where x varies from minus infinity to plus infinity. What is the value of k, right? So if PDF is given, area under the curve is minus infinity to plus infinity, f of x dx is equal to 1, right? This is the PDF equation. So substitute that minus infinity to plus infinity k into e power minus alpha x dx is equal to 1. So it's even, right? Because f of x is equal, you see f of x equal to f of x equal to k into e power minus alpha x, that is equal to f of minus x, right? So f of minus x is also k into e power minus alpha, minus of minus x, modulus of minus x is plus x only. So f of x equal to minus x, f of minus x, so it is an even function. So I change the limit, I take 2 into 0 to infinity, because it is an even function. K into e power minus alpha x, and x varies from 0 to infinity, so x takes only positive value, k is equal to 1, right? So 2k I take outside, integrated e power minus alpha x divided by minus alpha 0 to infinity is equal to 1, then it is equal to 2k by minus alpha, right? So here e power minus alpha into infinity, e power minus infinity is 0, then what do you call 0 minus e power 0 1 is equal to 1. This is equal to 2k is equal to alpha. This implies k is equal to alpha by 2. So what is the value of k? K is equal to alpha by 2. That's what they ask, right? That is the question. Yes. What is the value of k? K is alpha by 2. That's all about this session. I hope you understand everything very clearly. If you have any doubt, please ask me in comment section. Thank you.